Okay, let's have another example. So we're going to create a program that will input two numbers, the base and the exponent, and then compute and output the result using the formula x raised to y. Using the while loop, validate the value of x and y. Values must accept a positive numbers only. So let's first analyze the problem. So first is we need to create two input numbers, which is actually for the base and for the exponent. So if we're going to declare it on the declaration statement, I'm going to declare it as int, and then let's make it base variable and x for the exponent variable. So this is our input value. Okay, next we're going to compute and output the resulting formula of x raised to y. So in this case, I'm going to declare another variable and I'm going to make it prod. Okay, so since this is actually computing the values, so let's just analyze. Let's say, for example, okay, I have 2 raised to 4. So this is equivalent to 2 times 2 times 2 times 2. So in this case, 2 raised to 4 is equivalent to 16. Okay, so our base here is the value 2. So this is the base. And then our exponent is 4. That's the variable. And to process everything, we need to multiply 2 to itself. Okay, so we're going to make use of the prod later on. Okay, and then again, we need to have another variable. Let's make it int count. Okay, so this is actually count the number of iterations. So in this case, how many times we multiply number 2. So that's actually based on the exponential value, which is 4. Okay, so we have 1, 2, 3, 4. So in that case, we need the count. Okay, so in the executable, okay, so since again, as mentioned earlier, this is actually a controlled or fixed controlled loop. So we may use actually the for loop or the while loop. So in our case, okay, my example, I'm going to use the for loop instead of the while loop. So actually, you may try it also in the while loop. Okay, then after that, we need to have a validation before we start. Okay, after we already perform and compute the resulting value of the formula x raised to y, we need to also use the while loop to validate the value of x and y. So first is, after inputting or asking the user to input the value for the base and the exponent, we need to test. Okay, we need to test whether the value is valid. How are we going to identify whether it is valid? Value must accept the positive numbers only. So that means if the input value is 0 or negative, we must ask the user to re-enter the input value for the base and the exponent. So let's do that. Okay, so for the executable code, okay, so since we need to validate the value, so we're not going to make use of the for and the while loop. Instead, we're going to make use of the do while loop. So again, okay, for the do while loop, I'm going to use do begin, okay, and end. Then I'm going to use while, parentheses, semicolon. So this one is validating the base. Okay, so inside the looping, I'm going to display cout, enter base value. Okay, then I'm going to use cin and then use base. Okay, then we're going to test, no? We're going to test if the base is valid or not. So how are we going to validate the base? While, okay, while the base is less than or equals to 0, we need to ask the user to re-enter again the base value. So we're not going to accept any value of the base less than or equals to 0. So just to prompt the user that the input base is invalid, so I'm going to use a testing condition if inside the do while loop, and then I'm going to type base is less than or equals to 0. Then I'm going to prompt the user cout, okay, invalid base, please re-enter. Then let's put an L semicolon. Okay, so that's actually validating the base. Then we're going to do that also as well with the validating of the exponent. So I'm going to copy this and paste it here. Okay. So instead of base, I'm going to use enter exponent value. So this one, instead of base, I'm going to put x. And if exponent is less than or equals to 0, okay, then that's invalid exponent. Okay, please re-enter. Then while x is less than or equals to 0. So now, we validated already the base and we also validated already the exponent. So if both number is already validated, then we can proceed. Okay? So in this case, since we already validated both the exponent and the base, we now initialize the value of the prod. Okay? So prod equals 1. So y1, any number multiplied to 1 is equivalent to itself. Okay, then I'm going to use for loop instead of the while loop. Then I'm going to use for. Then I use count variable here. So I'm going to use count equals 1, semicolon. Then I'm going to test if my count reaches already the value of the exponential value. Okay, and then semicolon, then count plus plus. Okay, then begin and end. So inside the loop, okay, we're going to compute for the prod. So prod will be equals to prod times the base. Okay, so if the input base is, for example, 2, okay, so that becomes 2 times 2 times 2. Later on, we're going to simulate that. Okay, okay. Then after that, after performing the product, we can now display the value of the product. So let's display Cout base. Then we put caret, which is raised to x equals to, this is the prod and L. Okay, so that's the code. So let's simulate this one. Okay, going to use Excel to simulate. Okay, so for the simulation, okay, so for the simulation, okay, so let's simulate. So for the simulation, we need to have the entire variable. So we use the, first is we use the count, okay? And then we, first is we have the base, and then we have the exponent, then we have the count, and then we have also the prod, okay? So we ask the user to input, for example, the base and the exponent. So let's say, for example, the input base is 2, and the exponent value is 4, okay? So in this case, let's have this, prod is equals to 1, so we initialize that prod equals to 1. Then for count is equals to 1. This is 1. Okay. Is 1 less than or equals to 4? Yes. So we process prod. Prod is equals to prod times base. So that's 1 times 2. The new prod is 2. Okay. Then increment the value of count. Count plus plus becomes 2. Okay. Then go back to the testing condition. Is 2 less than or equals to x, which is 4? True. Again, compute for the prod. Prod is 2, multiply again to its base, which is 2 times 2, that's equivalent to 4. Then again, count plus plus, that's 3. Then test again the value of count. If reaches already the value of exponent, is 3 less than or equals to 4? Yes, again, compute for the prod. Okay, so prod is equals to 2 times 4, that's equivalent to 8. Then count plus plus, that's equals to 4. Then again, test again, is 4 less than or equals to 4? Again, yes. So process again the looping statement, which is prod is equals to 8 times the base, that's 16. So 16, okay. Then count plus plus, count becomes 5. Then we test again, go back to the condition. Is 5 less than or equals to 4? That's already false. So we stop the execution of the loop. And then let's display already the base. So what's the output again? So the output here is 2, which is the base, caret x, which is 4, equals last value of prod is 16. So that's the simulation for this program. So if you're going to test if you're going to test the validation of the base, so let's say for example, let's validate. So let's say for example, we ask the user to input for the base. So let's say for example, the user inputs -4. Enter the base value -4. Is -4 less than or equals to 0? True. So that's invalid base. Please re-enter. So while -4 is less than or equals to 0, that means we need to repeat the process of the do while loop and ask the user again to enter the base value. So let's say for example, that's already like 2 or 4. Is 4 less than or equals to 0? False. So that means we stop the execution of the do while loop and proceed to the next event or the next program or the next code. Okay, so same thing as the exponent. Let's run the code. So we ask the user to enter the base value. Let's say for example, I input -6. So it will just prompt invalid base. Please re-enter. If I input 0, it will not again accept the value. We only use positive numbers. So let's say for example, I already input 2. So we are now asked to enter the value for the exponent. Again, if I input a negative, that's invalid. Also for 0, that's invalid. Let's say for example again, I input 4. So the valid value for base is 2 and the valid value for exponent is 4. 2 raised to 4 is equivalent to 16. So let's try another value instead of 2 raised to 4. Again, while waiting, let's type calc for the calculator just to check whether our code is correct or not. So let's say for example, I input 6 and I use 5. Okay, so this is scientific. Okay, then this I'm going to use this x raised to y. So my base is 6 raised to, okay, 5. So equivalent is 7,776. So we need to have same value. 6 raised to 5 is equal to 7,776. Okay? So that's our second example.